This problem is solved using Coulomb's law. It says that two equal charged particles held 3.20 millimeters apart are released from rest. The initial acceleration of the first particle is observed to be 7.22 meters over second square, and that of the second to be 9.16 meters over second squared. The mass of the first particle is 6.31 times 10 at the minus 7 kilograms, and we have to find the magnitude of the common charge. The first step I did is to arrange the data that the statement gives us, and since the radius is given in millimeters, we have to convert it into meters, which is equal to 0.0032 meters. The statement tells us that the particles are equal charge, so we can say that Q1 is equal to Q2, and also due to Newton's second law, we can deduce that the force experienced by the first particle is equivalent to the force of the second particle. Now we are going to use Coulomb's law to find the magnitude of the common charge. To do this, we have to solve the equation for Q. First, I pass the radius by multiplying. Then, since Q1 is equal to Q2, we can put Q times Q2 like Q squared. At the end of the solve, we get that Q is equal to the square root of the force times the radius squared over the constant K. Now we can notice that we have almost all the variables to find the value of Q, but we lack the force. Force is equal to mass times the acceleration, and since force 1 is equal to force 2, we can use any of the accelerations given by the problem. In this case, I will use acceleration 1 since they also give us the mass 1. And the result of multiplying mass by acceleration is equal to 4.55582 10 times at the minus 6 newtons. Substituting the values into the equation, we obtain that Q is equal to 7.2046 times 10 to the minus 11, which is equal to 72 times 10 to the minus 12. The notation to the minus 12 is 4 picocoulombs, so Q is equal to 72 picocoulombs.